We are very excited today to present VMware's vision for storage and data protection in VCF. My name is Rakesh. I run product management for storage and data protection in VMware Cloud Foundation.
Yeah, my name is Duncan and Rakesh, Chief Technologist, and report into the same manager as Rakesh does. And my main responsibility has been vSAN for the last couple of years.
Okay, so we have a jam-packed agenda today. Very excited to present how we are thinking about unifying storage and data protection in VMware Cloud Foundation going forward. We have some exciting demos lined up for you on disaggregated storage and data protection and so on and so forth. I will also be presenting, giving you a sneak peek of some of the roadmap and future items. So having said that, I do have to put this up. There is information in this presentation that is confidential, it generally outlines Broadcom's product direction, but there is no commitment to delivering any of this functionality in any future time frame. Okay, and please do not share this across the board. All right, let's get started. I thought before I go into the vision for vSAN and storage and data protection in general, it'll be good to kind of give you a peek into how vSAN has been adopted. We've been in the market for over 10 years now, and we have 15 exabytes deployed all over the world, 15 million VMs, 1 million hosts. And that last one is very interesting. Our largest customer is approaching 800 petabytes, almost 1 exabyte. That's one customer globally across 5 continents, right? So it's pretty big. And the journey for vSAN has been very interesting, right? That very same customer I'm talking about started with 4 vSAN nodes. So what this shows you is really the power of scale-out, that scale-out technology that we've built with software-defined storage. You can start small, and you can scale into larger clusters. We support really large cluster sizes, and this can be extended to multi-cluster environments in VCF. So it's pretty exciting. Today, what we're going to be really talking about is how are we evolving vSAN to deliver multi-purpose storage in VCF. Right? Historically, if you look at it, vSAN has been primarily focused on delivering primary storage. So if you look at a typical customer deployment, all of you are very familiar with this, right? You have, let's say you have some private cloud, you have a couple of sites, you have a primary site, you have a secondary site. On the primary site, you typically put primary storage. You have VMs having access to different file types like block, file, and object. You back up that data just to make sure that, in the case of data loss, you're able to recover from that. And then you DR all of that to a secondary site so that if you have an entire site failure, you're able to recover from that, right? And some customers have access to the cloud as well. But what this environment really brings up is that a typical customer has multiple storage vendors, multiple storage UI consoles, you have multiple data copies that you maintain for your availability, and you have multiple sites. And this introduces a lot of complexity, right? Your block, file, object, backup, storage, they're all different. You have local snapshots, then you have remote snapshots. You replicate those snapshots to a secondary site. You have backups for ransomware recovery. You have to do archiving and compliance. You have to have object storage. And all these different workflows are completely different from each other. This really results in too many silos to manage. It is really a complex do-it-yourself kit, right? DR is hard, and ransomware recovery is even harder. So our vision from a storage and data protection standpoint is to be able to help you transition from the traditional way of managing storage to the modern way of deploying and managing storage. And in this, as you can see, as we evolve this, you can have vSAN both on the primary and on the secondary, either as HCI or disaggregated. You can have a cloud connection. You can And the software that we are going to provide you in VCF is going to leverage vSAN and VMware Live Recovery to help consolidate all of this and give you a global unified storage management and workflow. right? So that you can manage all of these, eliminate the silos, manage all of these from one central place. So, this is the vision that we've charted out. This is what it's going to look like. In the future, you have one central dashboard, one central landing page for storage and data protection. As you can see the storage sites. You can see what we call cyber vaults, or this is where you protect your data. And then you can see your archives as well. And you can actually trace the path of how your data is flowing from the primary to a cyber vault and to archives. And then our vision is to be able to provide you a single-click protect on VCF. Right? You want to do a single-click protect of a primary storage platform or an entire site, if you will, and we will talk about how we get there. But you can do a single-click protect of your environment, and with this, we would have unified primary storage, secondary storage, and disaster recovery. So that really leads us to delivering multipurpose storage for VCF. Right now, many of you are familiar with vSAN HCI. We started as HCI, right? And HCI is good for use cases where you have a balanced need for compute and storage. But what if your compute and storage requirements are very different? Let's say you have capacity-heavy workloads, right? You want to have the flexibility to scale compute and storage independently of each other. Right. For that, we have launched what we call vSAN Max, our disaggregated storage offering. So you can pretty much use either of these deployment models in VCF. We provide support for block. We've always done that. We've made lots of enhancements to our file services, right, in terms of scale and support for NFS v3 and SMB and all that good stuff. And we support partner-based object. We do have plans of delivering native object within vSAN in the future, and I'll touch upon that as part of this presentation. But really, once we do that, we need to have the ability to manage this data, provide snapshot management, not just for VMs, but also for Kubernetes. And a big focus of today's presentation is going to be the data management that we provide for VMs and Kubernetes. Once we have all of this, we will be able to extend vSAN from being a primary storage platform to other use cases such as disaster recovery, ransomware recovery, and even backup in the long term. So I'd like to talk about a couple of things today before we get into the vision, right? I talked about how we have these two deployment models, vSAN HCI and vSAN Max. HCI, as I mentioned, is really great for balanced workloads. If you want to symmetrically scale storage and compute resources, right? And we provide you unified lifecycle management for storage and compute in an HCI cluster. But what we've seen is that HCI doesn't work for everybody, right? Customers do have, in some cases, compute-heavy workloads, storage-heavy workloads, and then at that point, you do not scale linearly. So in order to enable asymmetric scaling of storage and compute, we launched vSAN Max last year. And we also talked about how we can consolidate extreme capacity. We are talking about up to 250 to 300 terabytes per node. So you can have a 6-node vSAN Max cluster with almost 1.8 petabytes. Right? Historically, we've never been able to consolidate that level of capacity on HCI nodes because you start running out of compute, and then you have to add another node in that cluster. And one big value prop of vSAN Max is you can independently lifecycle management of storage and compute. Right? So one misconception that has arisen, and this was the case, I think, when we launched it initially, right? Everybody thought vSAN Max is that vSAN Max XL configuration that you can see out there, right? Where you have 200 plus petabytes of capacity on a per node basis. And like I said, if you put 6 to 8 nodes, you get like 1.6 petabytes. Yes, that's what we launched. But in the last 1 year, we have scaled down the requirements for vSAN Max. Because what we see is that for many use cases, like let's say Oracle licensing consolidation, there are many use cases where customers want to disaggregate, but they want to start small as well. So as you can see, we've actually really scaled down the entry-level capacity here for vSAN Max. You see the vSAN Max XS and small configurations with much lower node capacities. And then, the minimums for the number of hosts per cluster has been reduced from 6 to 4. This is disaggregated storage. The purpose of these nodes is to run vSAN. It's not to run your VMs. So what you can really do is you can scale down the number of cores that you need, the compute on those nodes as well, so that you have just enough compute to run storage. You don't need to have those beefy HCI nodes that you normally buy. The memory requirements have come down as well, and we've also been able to reduce the networking requirements to 10 gigs per node, right? Again, it comes down to a sizing exercise. If you start saturating those network links with your workloads, even with a smaller configuration, then a 10 gig will not work for you, right? But the point here is that if you have smaller workloads and entry-level profiles that you need to enable, we have the excess support for vSAN Max. And this has been a big misconception. I've talked to many customers at this event, and everybody thinks, oh, vSAN Max is just a large-scale deployment. That's not true. And this is all, we have these platforms certified from all the major vendors, such as Dell, HP, Lenovo, and from your hardware vendor of choice. Okay, now let's talk about, with the new model, the new licensing model in VCF, you get 1 terabyte per core of vSAN with every VCF. So if you have 2,000 cores, if you're buying 2,000 cores, you get 2 petabytes of vSAN included as part of what you're buying, right? And what we now offer you is, okay, you buy just one thing. You buy VCF, right? You bought 2,000 cores. You have 2 petabytes. And what you can now do is you can deploy vSAN either as HCI in a workload domain, let's say in this example, 500 terabytes, a second workload domain where vSAN is remote with vSAN Max, that is another 500 terabytes. And then I've seen customers do this as well. You can actually mix and match HCI and vSAN Max in the same workload domain, right? So you can have a mix. So let's say you have an HCI cluster running right now, you run out of capacity, no problem. You can actually stand up a vSAN Max cluster and mount that vSAN Max data store remotely on the HCI cluster as well. So this is a scenario where a customer is effectively using the entire storage entitlement of vSAN as part of your VCF license. Okay? And let's say you need more capacity, you can always buy add-on vSAN to this particular deployment. Okay. Now let's talk about a more common scenario that I think most of you will be running into with this new model, where you're not effectively consuming the entitled vSAN and VCF. Why is that the case? So in this example, let's say you have a workload domain with vSAN HCI or even a mix of vSAN HCI and Max, you have 1 petabytes there, okay? Now in the second workload domain, right, for various reasons, because you have legacy workloads, you have several workloads running on legacy traditional storage platforms, and let's say your external storage array that you're using, let's say that's on fiber channel storage, you're not ready to depreciate that asset yet. Okay, you have another 2 to 3 years to depreciate that asset. I get that, right? So that's the case where in this particular scenario, you're still running an external storage array. What you can do over time is as you depreciate that asset, you can replace it with vSAN Max and then effectively consume the entire 100% of your storage entitlement by replacing that external storage with vSAN Max. So this is the journey that we have been talking to several customers about. We have migration tools that can help you do this, but essentially I think this is the path that will help you effectively consume all the vSAN that is included in VCF. With that, I'm going to hand it over to Duncan, who is going to show you an exciting demo of vSAN Max. He's going to introduce what we have launched with vSAN Data Protection in 5.2, and then he's going to show you an exciting demo of vSAN Data Protection in 5.2 as well. So Duncan, take it away.
So before I get started, who of you has already played around with vSAN Max in any shape or form, by show of hands? Okay, that's what I figured. It's just one person, and I know the guy, so I figured he would have been playing around with it. And whom of you is actually running a stretch cluster configuration? Okay, that's also a few folks. So this demo that I'm about to show is something that we are newly introducing in a future version of vSAN. If you look at vSAN Max today, then of course you're already capable of creating this storage-only solution based on vSAN Max. The biggest challenge that we have today with vSAN Max is that although with vSAN Max you can create a stretch cluster configuration, you cannot share that stretch cluster configuration to vSphere only clients, meaning a client that doesn't have vSAN installed and configured. The reason for that being is that fault domains, that construct that allows you to create a stretch cluster configuration, does not exist within vSphere. So what we've been actively working on is developing a solution where we can actually create these fault domains within vSphere only as well. So that's what I'm about to demonstrate. So as you can see, we have a brand new environment here, and I have 3 clusters, 2 vSphere compute only clusters, so they're not running vSAN, and then I'm going to create a vSAN Max cluster. In this particular case, I haven't enabled it at all. So what we're going to do is we're going to get started by enabling vSAN Max. And as you can see, we have different options available here. You can do an HCI cluster, you can do a vSAN compute cluster, or as I said, we can create a vSAN Max cluster. So I'm going to create a vSAN Max stretch cluster configuration just so you can see and experience how easy it is to do that. In this particular case, of course, the first thing we'll do is we'll check the compatibility guide to see if all of the components have been validated, and they are. And then next, of course, what we're going to do is we're going to claim all of the different devices which are part of the hosts that belong to this cluster. These devices are going to form that vSAN data store. The next thing that we do is we create our fault domains. So these are the 2 locations that we need for a stretch cluster configuration. But with the stretch cluster configuration, we also need to have a witness location which helps us in case one of the 2 sites ends up failing. So that's what we end up doing here. We select that witness which runs in a 3rd location, we select the devices of that witness, and then we can start creating that cluster. First thing that is happening now is all of the local devices that are part of these hosts, that are part of that cluster, are going to be formatted with our file system. The next thing that happens is that we create a storage pool on each of these hosts, and then all of these storage pools combined will create that vSAN data store. After that has been completed, which typically takes about 10 to 15 minutes, of course, the next thing that we can do is we can start deploying virtual machines, and if you already have a policy available, those virtual machines will be stretched as we have these fault domains configured. So that is what I'm going to show you after we've connected our vSphere client back to the vSAN Max data store. Now, as you can see, there's this fault domain screen that popped up. So in this particular case, that vSphere client or that vSphere cluster is also a stretch cluster configuration. As I said, normally you wouldn't be allowed to do so to create a connection between vSAN Max and that vSphere stretch cluster configuration, but in this particular case, we're actually capable of doing so, and it actually also allows us to specify if these sites or if these servers are part of the same sites or not. And this basically enables us or ensures us that from a performance perspective, if a virtual machine writes within that vSphere only cluster and it writes to that vSAN Max data store, that we're not traversing the ISL unnecessarily. So after we've made that connection, the next thing that of course we can do is we can deploy a virtual machine, and after we've deployed a virtual machine and we've selected the correct storage policy, that virtual machine which lands on that vSphere only cluster is now going to be provisioned on vSAN Max storage in a stretch cluster configuration. So we've deployed the virtual machine, we can go back to vSAN Max and we can look at the virtual objects and inspect the objects and actually can see that the data is now automatically stretched across those locations. Even though within that vSphere only cluster, we don't have storage available locally. That is remote storage, as I said, through vSAN Max. So this is one of those capabilities that we'll be introducing in the very near future, hopefully. Now, just to be clear, as Rakesh said, we're not actually sure when and if it will make the release. So just that caveat, I just want to place that caveat out there. So that was the first demo that I wanted to show you. The second thing that I want to talk about is vSAN data protection. Now, there are a bunch of vSAN customers already here, and there are, of course, vSAN stress cluster configuration customers here. But by show of hands, are people already using vSAN ESA? Okay, that's a bunch of people. So actually, probably 20% of you, which is a significant number. Now, for those not using vSAN ESA yet, or for those who haven't actually read into some of the capabilities of vSAN ESA, before I actually start talking about vSAN data protection, I do want to point out that vSAN data protection is fully powered by a new snapshotting capability. And the reason I want to point it out is because if we look at some of the snapshots that we've seen in the past, both with vSAN OSH, so the original storage architecture, but also, for instance, with VMFS or NFS or for any of the other storage protocols out there, you've probably experienced some challenges with snapshots at some point in time in terms of performance degradation when you start creating multiple snapshots. This is something that we actually solved with vSAN ESA specifically by creating a completely new snapshot mechanism. The snapshot mechanism that we've introduced actually does not create additional copies or additional objects to place the data in, or doesn't create additional files like just with VMFS, but we actually make a copy of the metadata structure and we do the IOs to the existing objects that are available. That also means that from a performance perspective, you will not see any performance degradation, whether you have no snapshots, one snapshot, or maybe even 200 snapshots. So that is something that we've introduced in this platform. Now, of course, with that, you could start creating all of these different schedules, and we actually have multiple capabilities available within the platform already that allows you to do so. But of course, the plan, as Rakesh also alluded to, is to actually enable you to start offloading those snapshots elsewhere. Now, of course, what I'm going to talk about is what we have available today, and then afterwards, Rakesh is actually going to talk about some of the additional capabilities that we're planning for in the future on top of that. Now, what you see here up on the screen, local protection as well as remote protection, is something that we already have available in the platform. Now, when you look at that solution, I think one of the most interesting capabilities is that it's all driven through the exact same UI. It's all driven through the policy. And within that policy, we actually allow you to create what we call protection groups. And those protection groups can basically be any type of combination in terms of how you would like to store those snapshots locally. So you can have one snapshot per hour, save it for a week, or maybe one snapshot per week, save it for a month, one snapshot per month, save it for 12 months, etc. There are a couple of things that I do want to point out, which I think are important for those who are actually managing the systems. If you do start creating these protection groups, you're allowed to place a single virtual machine in up to 3 protection groups at this point in time. So that is something which I think is important to realize. And when it comes to these schedules, you can create up to 10 different schedules. But I would recommend to start simple, because if you start creating 10 different schedules, it will become rather complex, and you may end up in a situation where you'll end up with, tens of thousands of different snapshots and making it almost impossible to figure out where you need to recover from. Now, the other thing which I think is very interesting about the solution that we've created, and I'm actually going to show that in the demo as well, is the way that we allow you to select those virtual machines. We've added what we call a dynamic way of selecting virtual machines, simply by providing a statement. So you can add a regex, and in my example, for instance, I'm going to select all of the virtual machines which starts with my initials DE. So I'll show that in the demo what that actually looks like. So let's take a look at the demo right now. So if you look at this environment, which is actually my own lab, what I've actually already done here is I've deployed the Snap Manager appliance. This is the very first thing you will need to do if you want to do anything with these vSAN snapshots from the interface that is available within the UI. That interface will not be available until you've actually deployed that Snap Manager appliance. So you need to install and configure it. And after you've done so, and you have vSAN ESA, and this is crucial, then all of a sudden this new section within the UI pops up, which is called vSAN Data Protection. Now, if you go to that section in the UI, you will have multiple things to your disposal. First of all, of course, we will provide you all of the information that you need to see how many virtual machines are protected, how much data is being stored on the data store already, and how much capacity is being consumed by those snapshots. Then, of course, on top of that, you can also start creating what we call protection groups. Now, just to be clear, these protection groups are not consistency groups at this point in time. That is something that we may or may not implement in the future. Now, what we're going to do is we're going to create a protection group. And as you can see, you have an option to make that protection group immutable. Now, I want to point out, if you select immutability mode, you cannot delete this protection group anymore. So that is something to consider when you create a protection group. In this case, as I said, I will be creating a protection group with a dynamic naming scheme. And I'm going to select all of the virtual machines which belong to me, so I'll use my initials. And if I add virtual machines over time, they will also be automatically added to this protection group. So in this case, there are 2 virtual machines which belong to me. But if I would add a 3rd virtual machine, it's going to automatically be added to this protection group. And the schedule that I've created from a snapshotting standpoint will also be automatically applied to those virtual machines. Now, I'm going to create a classic schedule, 1 snapshot per hour, save it for a day, 1 snapshot per day, save it for a week, and then 1 snapshot per week, and then save it for a month. Of course, I could also save it for a year, whatever you like to end up doing. After that first initial protection group for these 2 virtual machines has been created, it can take, in this particular case, all the way up to an hour before those virtual machines will be protected. So if I would click on the protection group, the next thing that I can do is I could, for instance, manually take a snapshot to ensure that all the VMs that are part of this protection group are instantly protected by that local snapshot. So that's what I'm showing here. After I've done that, of course, the UI is going to be updated and it's going to show some information in terms of how many snapshots we have, when the first snapshot was taken, or when the oldest snapshot was taken. All of that information will then be available within the UI. Now, of course, also, when you've created these snapshots, you can also see these snapshots for all of the virtual machines that are part of that protection group in the UI as well. The other thing, of course, what you can do is when you've created these snapshots, you can start recovering virtual machines. Now, there's a couple of things I need to point out. If I would click recover here, or restore here, the virtual machine that I'm restoring is powered off. So it's powering off the virtual machine and then going back to the particular point in time. So I'm not going to do that. What I'm going to show you here is a clone of a snapshot. That is also one of those capabilities that you have available. Now, the nice thing about this solution is that we're not copying any data. So this is kind of like a linked clone, and which also means that when we create that clone, it's going to be instantly available. So I didn't speed up the video here. It literally takes seconds for that clone to pop up in the UI, to be registered against the vCenter server, and now I can power it on and can start using it. One thing I need to point out is that, of course, it's a linked clone configuration, is that it's going, if the, for instance, the IP address is hard-coded within the virtual machine. If you power it on, you may have 2 similar IP addresses on the network. So in some cases, you may want to make sure you disable the network card and make those changes first. Now, another thing that you could do, besides using that data protection overview, you can also just simply go to the virtual machine to look at all of the different snapshots that have been created. So you have that capability here as well. So as you can see, this virtual machine actually belongs to 3 protection groups, and it has many different snapshots. And I could pick any of those snapshots to start restoring those VMs or cloning those VMs. The last thing I want to show you is that from a UI perspective, of course, we have all of those capabilities available. But we also have an SDK available. And as soon as we released an SDK, of course, William Lam instantly started creating these Power CLI commandlets. And the Power CLI commandlets basically allow you to assess how many protection groups you have. It enables you to not only list those protection groups, but you can, on top of that, also, for instance, delete those protection groups. The other thing that's probably useful to know is when you delete those protection groups, it can, or it may or may not, depending on what you specified, either in the UI or through the Power CLI commandlets that are available, it can also delete all of the snapshots that are associated with that protection group. Now, mind you, if you decide to delete all of the snapshots that are associated with the protection group, of course, all of those snapshots will be gone. There is no way to recover those snapshots at this stage, so be very careful in terms of what you'll end up doing from that perspective. Now, not only are there, of course, PowerCLI command that's already available, on top of that, we have an SDK, and of course, we have a fully supported API available as well for customers who would like to use that. So hopefully, with that, I've been able to show you not only what the power is of vSAN Max and those stretch cluster configurations, which have been heavily simplified, but on top of that, also have been able to show you what the power is of vSAN snapshots and what we're capable of doing with it now, and hopefully also will be capable of doing with the future. I'm going to give it back to Rakesh, who's going to talk about the roadmap. Rakesh?
Thank you, Duncan. That was a great demo, right? Now, I'm going to talk about, so Duncan showed you two things. He showed you a demo on vSAN Max, and he showed you a demo on vSAN data protection as it exists today. Both vSAN Max and vSAN data protection with our deep snapshot chain is very foundational and very fundamental to the new markets that we plan to enter going forward, right? So another thing that is really foundational is the ability to provide global deduplication. As you start maintaining large number of snapshots, opening up new use cases for vSAN Max as a secondary storage target, efficiencies that you get from something like a deduplication becomes super critical, okay? So, you know, it took us a while to build vSAN global deduplication. This time, we wanted to get it absolutely right. So, first of all, our goal is to be able to provide you the highest space efficiency with the lowest performance impact. Now, those of you who are familiar with OSA, you know that deduplication is done when you destage the I/O from the caching tier to the capacity tier, right? And that has a certain performance impact because you're doing it while the I/O is getting destaged. With VCF9, we plan to deliver vSAN global deduplication where the dedupe domain is at a cluster level and the deduplication itself is done as a post-processing activity. We throttle down the deduplication if the VM-IO is high, and we throttle it up if the VM-IO is low. So it's very adaptive in that sense. So there's a very, very low 5% impact on the overall resources while we actually run dedupe in the background. And if you look at it, you know, in ESA, if you have a 16-node cluster now, as an example, you are actually going to be, we are going to be deduping at the domain of those 16 nodes. So you're going to be deduping across those 16 nodes. This is going to lead in much higher storage efficiency, much higher space efficiency than what OSA delivers today, because OSA dedupes at a per disk group level. Right? So that's a fundamental difference. We ran some TCO models. We looked at the kind of savings that you can actually see. Dedupe itself lowers your entire TCO for VCF by 4%, which results in a 10 million savings over 3 years. This is for a 10,000 core VCF deployment. Your savings are going to proportionately be higher if your deployment size is much higher than 10,000 cores. Okay, so and many of our customers like to compare the storage savings with what you get with external storage arrays, right? And I took a conservative one here, but essentially you get up to 46% lower dollar per terabyte than traditional storage if you were to compare the effective capacity. Now, by effective capacity, what I'm referring to is you take raw, and then you take out you know, you bring it down to the usable capacity based on the storage efficiency that you're getting, which includes what you get from compression and dedupe, and then add the overhead of RAID and any other slack space or something like that. So that's effective capacity, apples to apples comparison. We are 46% lower than external storage, and we are up to 27% lower than ESA without dedupe. The other thing I keep getting asked is, we have several customers on OSA. How does this compare? How does the dedupe savings compare with OSA, right? Now, keep in mind, when we did this model, we are using maybe slightly cheaper drives on OSA because OSA typically runs on SAS and SATA drives, so we've used lower drives and cheaper drives. And for ESA, I used the read-intensive drives as a comparison, which maybe are about 20% more expensive than OSA. Despite that, when we do an apples to apples of the deduplicate, you turn on dedupe on OSA versus ESA, despite having more expensive disks on ESA, you still get about 36% higher space savings with ESA compared to OSA. So some interesting numbers. I'm sure I'd like to hear from you all when you try this out. When we have this in our first release, I'd like to get feedback from all of you as well on what you're seeing. All right. So we talked about how we are going to be using global dedupe to lower your TCO even further. I'd like to now talk about how we are extending the data protection, the demo that Duncan showed today for local operational recovery. How are we extending that to disaster recovery, supporting disaster recovery from site failures, right? Everything that we are doing right now is foundational to what we are building in the future. Right? So we talked about how with VCF 5.2, we have local protection, we have efficient and deep snapshots. Duncan showed you how to schedule, retain those snapshots, how to create those deep snapshot chains, and how you can do a quick recovery from one of those local snapshots. We are taking this to the next level in the next release. We plan to extend this to provide disaster recovery from site failures with a low RPO as well. Right? We are unifying the appliances for SRM VR. I'll talk about that shortly. And in this particular case, your vSAN Max can either be a source or a target as well. So, first and foremost, although we are leveraging some of the existing technologies we have like VR and SRM and VLR, I'd like to highlight that this is an 100% on-prem solution. You don't need to send your data to the cloud. Because we heard you very loud and clear that as VCF customers, many of you require a 100% on-prem solution. We provide, as I mentioned, we provide up to 200 deep snapshots per VM. Theoretically, we can support unlimited snapshots. For the first release, I'm just restricting it to 200, but I'd like to hear from you all on any use cases where you need more than 200 snapshots for VM. Potentially for things like cyber recovery that I'm going to talk about, ransomware recovery, but I'd like to hear from you as well in the future once you adopt this. Okay, so what does this look like, right? I wanted to do a quick comparison of, from an entitlement standpoint, you get everything that Duncan showed you for local protection, you get all of that with VCF, okay? If you're VCF, you get all of that. But to get the advanced vSAN to vSAN replication and DR with SRM, for that, you will need to you're required to add the VLR license, which is an add-on. Right? And it's priced based on the number of VMs you want to protect and the capacity you want to protect and so on and so forth. So that's one thing, right? How does this compare with VR? I know many of you must have used VR in your environment. How many of you have used vSphere replication for anything? Yeah. So you must be familiar with what VR offers, right? But vSAN data protection, we are not only able to deliver RPO of 1 minute, but we are able to do that by supporting a deep chain of 200 snapshots. Right? As Duncan showed you, you can create those, you can put those snaps in multiple protection groups, right? You can have multiple VMs in a protection group, and then this gets automatically ingested into SRM. So there's a very tight integration between the vSAN Snap Manager and SRM. So if you have to do a recovery for that specific protection group, it automatically shows up on SRM. It's fully automated. Right? And all of this is fully integrated into the VC UI. Those of you who are familiar with vSphere and vSphere replication, you don't have all of that. You don't have all of those workflows. In VR, you can only replicate one VM at a time. Here, you can do it with multiple VMs with protection groups as well. And we have an API-first approach, so we are going to be providing a full vSAN DP API for you to be able to integrate with a product of your choice. Okay, so this leads me to my last slide, right? So we talked about how we introduced disaggregated storage with vSAN Max. Then we talked about how we can enable local operational recovery with DPSA snapshots, right? And we demoed both of these today. Then we talked about in the next release, I'm going to give you global deduplication to reduce the TCO even further, for use cases where you're shipping these snapshots to a remote site and you want to really bring down the cost of that storage, right? And we talked about providing vSAN to vSAN replication to replicate that data into the remote site for disaster recovery use cases, right? After all of that, this is what provides us the foundation to deliver on-premise ransomware recovery. So you're all familiar with VLR, you're all familiar with what we can offer there, but that was a cloud-based solution. You had to ship your snapshots to the cloud. Here you don't have to do that, right? We are bringing all of that into VCF as a 100% on-prem solution. We'll be offering you a templatized VCF-based IRE environment, so we'll give you a template on how to do this. Of course, there will be a deep history of immutable snapshots in the vSAN, which is stored as a data vault. And we have a unique IP with our VLR solution, which is an integrated EDR for behavior analysis of infected VMs. We'll be able to analyze which VMs are infected. You'll be able to go and pick the clean snapshots. We're going to give you workflows to give you pick the clean snapshots in case you're attacked by your primary site is attacked with ransomware. You'd be able to go to the secondary site, do an EDR, behavior analysis, and identify the infected VMs and disinfect them using our snapshot technology. Right? This is completely air-gapped, so as you can see, you can air-gap the east-west isolation using NSX, so you can air-gap the secondary site from your primary site, which is a very, very critical requirement. Because you don't want anything on the primary to infect your secondary. And the restore point for determining which snapshot to select to recover will be entropy based. And so we have all of this built into our VLR solution. So our plan is to offer this in the first, offer this in our next release. So looking forward to putting this together and looking forward to getting all your feedback on this. So that was my last slide. I think we can open it up to questions.
Sounds good. If there are any questions.
If there are any questions.
Or any feedback is welcome as well. So especially for those already using vSAN, vSAN ESA, if there's anything which is not working, anything you're challenged with, he is the lead PM, so I'm going to point to him if something is broken, but he can fix it, or he can get it fixed, so let us know.
So let's say a ransomware event, space is going to start getting consumed like crazy, right? Do you have any protections in place to stop overrun of the vSAN data store in that type of scenario?
We do. And well, protection would be more about we start with alerting you. We start sending you notifications. And then we will be putting some thresholds where beyond, I don't know what those thresholds are, but beyond X%, we won't allow you to put more capacity there. At that point, we'll have to start stopping you, and you'll have to scale out by adding more nodes to the cluster.
Any other questions?
Are you guys looking at enhancing, putting the host, the hyperconverged in the maintenance mode, evacuating it so you have more than one going into maintenance mode at a time?
Yeah, so the question is around maintenance mode, if we're planning on enhancing the capability to place more hosts into maintenance mode at the same time. And that is probably one of those most challenging things, especially with the way that vSAN is constructed today. It's an object-based storage solution. So if we would provide that capability, the very first thing that we would need to do is try to figure out if there are two hosts which are not running components of a particular virtual machine. So chances of that happening, depending of course on the size of your cluster, are fairly limited. So that's one of the reasons we haven't actually explored that. It is something that we brought up with the engineering team, mainly because people want to speed up, for instance, a scenario where they want to go from version X to version Y, just want to decrease the amount of time that it takes to upgrade. But it's a fairly complex process, unfortunately, at this point in time. Yeah, and that exactly increasing the number of copies of the data itself, that could be something that could work. However, one of the challenges, of course, that you would have is if you have a RAID 5 configuration or you have a RAID 1 configuration, and you change it to a RAID 6 configuration, so RAID 5 to RAID 6, that would trigger a full rebuild. So the amount of time that it would take to complete the rebuild also introduces risks. Of course, if you would have a RAID 1 configuration, you have 2 copies of the data and you extend it to 3 copies of the data, then that would be different. But RAID 5 to RAID 6 would be a full rebuild, unfortunately, and RAID 1 to RAID 5 or RAID 1 to RAID 6 would also be a full rebuild. So from that perspective, I'm not sure if that is very useful. To mitigate some of the risks, by the way, during maintenance mode, we have implemented things like, for instance, delta copies. So majority of customers, when they do maintenance mode, they don't move out any of the data just to reduce the amount of time that it takes. But of course, depending on the churn rate you have, so if you have a high transactional database, for instance, then yeah, we need to resync data, and it could take a significant amount of time. The only thing that helps you with that is faster devices and a faster network. Unfortunately, well, some of the vendors may say fortunately,
Yeah.
like the Intel folks. Any other feedback, any other comments? Well, if there's nothing,
We're right on cue.
yeah, I would like to thank everyone for attending. Hopefully it was useful, and hopefully we'll see you guys again next year. Thanks.
Right. Thank you.